Hi science students, in this video we're going to discuss energy. So firstly I'll define energy. It's the ability to do work. So by work, of course, we mean the scientific definition of work, which is a force applied to an object multiplied by the displacement that force causes. Okay, but you know, if you're thinking perhaps like, oh, I just haven't got the energy to do any of this energy work that we're working through, well then that's a different story. But this is the definition of energy, the ability to do work. It's measured in joules. Well, that's the standard unit, is the joule, with a capital J for that unit. Of course, energy can be measured in other units as well, but the standard unit is the joule. It is a scalar quantity. Now, you may be aware of the different forms of energy. So with this energy can be, we're going to write down different forms of energy. All right. Now, you might be aware of some of those. So maybe you want to pause the video and see how many different forms of energy you can figure out or remember, think about. And then I'll write down a few of the important ones for us. Okay, so these are some of the important forms of energy for us. Thermal energy, did you have that? Basically, if you'd said heat energy, I'd be happy to accept that, so heat. So thermal energy could be as a result of, say, a reaction, a chemical reaction occurring, like a combustion reaction, basically a fire, or some other type of chemical reaction like an exothermic reaction, which we'll discuss more in chemistry. Perhaps also you might notice that if you rub your hand on the carpet, or if you land on the carpet on your knee, you might experience some heat, carpet burn, as a result of friction. So friction can cause thermal energy to occur as well. Another form of energy is kinetic energy. So that is the result of the movement of an object. So if something's moving, it has kinetic energy. We also have potential energy. Now, there are several forms of that, which I'll detail. Gravitational potential energy. Okay, so when we lift objects above the Earth's surface, we're producing gravitational potential energy, because they then would have the ability to fall, which would convert into kinetic energy. Elastic potential energy is another one. So if you grab a rubber band and stretch it, provided you don't go beyond its elastic limit, the rubber band will reform its original shape. So that, once again, is producing kinetic energy. That would mean that the elastic potential energy is energy stored within the material, within the bonds within the material, or the fibers of that material. Similarly with chemical potential energy, so we can have chemical potential energy in your muscles, within food, within petrol. There is chemical potential energy, and when a chemical reaction occurs, that energy can be released. Okay, so I'm going to just show you guys this slide. I'm going to give you a couple of a few notes to write down, and then a couple of examples to consider. First off, conservation of energy. Now, energy cannot be created, nor can it be destroyed. Let's write that down. So that might seem counterintuitive, because you might be thinking, well, you know, what if I go for a ride on my bike and I stop pedaling, all of a sudden the bike will start to slow down. So that friction is reducing the kinetic energy. And aren't I destroying that kinetic energy? Well, no, that kinetic energy is just being converted to other forms due to the friction. I might just leave that for you to consider for one of the examples that we're going to do. So rather than energy being created, energy being created or destroyed, the amount of energy in the universe, as far as we're concerned, is fixed. And so we're merely converting it from one form to another. And that's what the examples I'm going to give you to consider are about, is considering what energy forms are being converted into what. So energy can be transformed or converted from one form to another. Righto. So I'm going to give you guys a couple to consider. This one here with the person riding up the hill and down again. Oh, that's not very good. But a person riding a bike up a hill. Okay, can you detail the energy transformations that occur in that situation? The next one, hydroelectric power plant or power station. How could I leave that out, given Tassie's strong association and reliance on hydroelectric power for all these years? Okay guys, so pause the video and see if you can detail the energy transformations that occur. You don't need to follow the same format as what I'm going to give. You could write this as a sentence, you could make a bit of a flow chart. Don't get too caught up in that. There's no hard and fast way to detail answers to these, but just have a go at it yourself and then consider what I show you. So go ahead and pause the video. Okay guys, so if you're ready, I'll detail these energy transformations for you. Now, just going to show you for the person riding a bike up a hill. Okay, so a bit of an example here. Kinetic energy, a person moving, becomes potential energy as they go higher up on the hill. So they're higher above that reference point. Okay, so the higher you get, the greater the potential energy of that object. We're going to discuss how to calculate gravitational potential energy, and that's what I should be saying here. This is gravitational potential energy, not just potential energy. And then when we get to when the cyclist gets to the top of the hill, that potential energy is converted into kinetic energy as they roll down the other side of the hill. Okay, now slightly more detailed than that. I'm going to go even further and start back at before they were pedaling up the hill. Okay, and I'm going to consider that there was chemical potential energy in their muscles. Okay, I'm just going to use PE, chemical potential energy, for PE for potential energy, and the person converts that by pumping the pedals, and they are now moving, so they have kinetic energy. Now, as they hit the hill, they will slow down. So we're considering, I suppose, that they stop pedaling, just simplification, and they roll up the hill and they slow down, so their kinetic energy reduces, and by the time they get to the top, it's turned into potential energy. Oops, I should say gravitational potential energy, sorry. So I'll say gravitational PE. And then they roll down the other side of the hill, so that gravitational PE is converted back into kinetic energy. And we tend to just simplify these a little, you know, we don't go too crazy, but I suppose we would also say that, you know, alongside this kinetic energy, if you'd stated that there was heat energy or thermal energy created by the friction, and perhaps even sound due to that friction as well. That would be a good thing to do as well. Okay, so see how your answer compares to mine. Okay, a hydroelectric power station. Right, so I'm going to have a look at this animation here. Now, just ignore this bit of this GIF, the heat energy. We're not considering that part of the cycle. We're going from here onwards, the gravitational potential energy. So what they do is they build storage or an impoundment, like a dam, up very high. So in Tasmania, that most of those dams are up in the highlands of Tasmania or in high places around Tassie. A lot of natural lakes that have been either or natural lakes that have been altered so that they can fit more water in them. So Great Lake is an example of a lake that's been enlarged, I suppose you would say, and Lake Pedder as well. A very famous example is Lake Pedder. That's a lake that has been vastly enlarged. It was quite a small sort of a lake, probably, I'm making this up a little bit, but probably only a few football fields sort of size, 2 or 3 football fields, something like that. Not exactly sure, but it was small, and now it is massive. They flooded in an entire valley. So a massive increase in size for that lake. Also would like to point out that Great Lake is also known by its indigenous name these days, Yingina. So Great Lake or Yingina, one of those lakes that has been made larger. And there's lots of examples of this, but also examples of riverbeds that have been flooded. Like Lake Barrington was originally just the 4th river, went all the way up behind Cradle Mountain, but now Lake Barrington is a large impoundment, and there's a series of lakes up through that way. Also on the Mersey River, that series of lakes have been created, like Lake Rowellan and Lake Parangana in that area, and they're for hydroelectric storage. So the rain falls and the water is captured in a dam, and it has gravitational potential energy. Now that water is then released through a pipe and the water moves. So that converts it to kinetic energy, as you can see going down through the pipe. Now eventually the water will hit the generator, and inside the generator is a turbine. So the turbine will spin, and that converts kinetic energy into electrical energy. Now you'll study the phenomena behind that when you do physics, or if and when you do physics in Year 12. But there's a very good reason why spinning a turbine will create electrical energy, but we don't need to consider that for our course. Okay, so let's detail these changes. We have gravitational potential energy. That gets converted into kinetic energy. And finally, electrical energy. Righto everyone, so I'll detail some questions for you to try, in which you can practice some energy transformation type situations. So have a look in the description for the video for those.